Hey y'all, my name's Tyson, and today let's talk about creating real, usable, 3D printable threads. Yeah, so we want to make threads that don't actually just look like threads. We want to make working threads, exterior and interior, and not just any threads, because we are going to talk about just creating your own sizes, but we also want to be able to create real standard sizes that work with some of the standard hardware you can find out there. Now, this should work in imperial or metric, and I think we'll cover this in two videos. So this first video, we're going to cover kind of the essential nature of some of the things you need to know and how to create just some generic threads that you can print. And in the next video, we'll go into kind of standard sizes and how you can create threads that are going to match up with, like I say, some real world standards. I want to give a quick shout out to our friend Dave Richards. I spoke to him a decent amount on this topic, and he gave me some great tips. So thank you, Dave. But with that, let's jump into it. Okay. So this is just an example of some of the things that we might create, right? Different sizes. Like I say, these ones are generic, just made up ones. These ones are more examples of some real world size threads. We're going to be able to create both. In this first video, we're going to talk about just some of the basic understanding you need to know and create something more like this. In the next video, we'll do something more like this. All right. Okay, a few things to start. This process relies on extensions. Now, first of all, you need Cleanup and Solid Inspector. Those are just good anytime you're dealing with 3D printing, and they're just useful overall. One method we're going to explore uses Curve Maker and the Helix version of it, which is this extension, and the Upright Extruder from Christina Inneroth, which is this one. We're going to focus on those more in the next video. In this video, we're going to explore the Whirl extension. Now, the process is going to be fairly similar, but we're just going to show both so you have those options. All right. Okay, here, if you've never messed with threads, here's a few things that these are just the basics of thread geometry and how threads are made. All right, so you have typically your outer or major diameter or radius, it might be listed as, which is the outside of the threads. And the minor or inner diameter, which is the inside, between the inside, or the root, because here's another common term you'll see. The root is the inside part of the tooth, and the crest is the outward part of the tooth. Another thing that you'll see and you absolutely need to know is the pitch. The pitch is the distance between each of the teeth. So you can see this is between centers here. And another thing that will commonly be used is the angle. A very common angle is 60 degrees between teeth. That's both in metric and imperial. That's pretty standard for most just general purpose screws or bolts. So we'll be using 30 degrees a fair amount. It's just a good place anyway. It's also a nice, like say we're going to 3D print these. 30 degrees is a nice angle that's typically doable by most materials and printers without support, which would be ideal for us. So those are a couple of the general terminologies. And the process that we're going to do, just to overview it, is like this. So if we want to create, like I say, external and internal threads, we always start by creating external threads first. And then we're going to use those to create everything else. And the process is similar. This was created with the whirl extension. But if we use the other process where we're drawing a helix, then we'll be using upright extruder to create a similar shape as this. Like I say, we'll do that next time. We're going to explore more of whirl this time, but this version, ultimately you can get very detailed and if you really want to focus on accuracy, it probably is the better one, but I still really like both methods, having both. So we create the spiral or teeth, and but no matter what method you use, they won't be a solid. So then we need to create that inner column, if you will, and create a solid. And with that solid, we can chop in here I've chopped the top and bottom off using the solid tools. If we wanted to create a bolt, we could join another shape with it. If we wanted to taper one end, we could cut away, something like this. So we're just shaping it, and the inner threads will be created again by taking a shape like this and intersecting these. So if I've got my solid tools, I'd say cut this shape away from this one to create the inside threads. That's the process we're going to be using. Create our spiral, make it a solid, and then manipulate that solid how we want. Okay? All right. Excuse me. Like I say, we're going to start with the whirl extension. So from the extensions menu, you can find this, and we're typically just going to be drawing with dialogue. And it's going to bring this up. Well, if you've never used this extension, this may be like, what are all these numbers? So here's what they are. A couple things. I'm going to cancel this. And these relate to what we're talking about here, where we need to know the outer diameter or radius. It's going to ask us to input it in a radius, kind of like SketchUp circles do. The tooth height is not the pitch. Remember, the pitch is the full distance between teeth. The tooth height is just the tooth. The edge height is that crest. By the way, a lot of screws, bolts, they might have a rounded crest or a rounded root. We're not going to worry about that. You can add something like that if you want, but we're just going to be keeping these straight. And finally, the tooth length. Okay, so let's create a generic, let's say we're creating a large bolt. And to do this, I want to kind of draw out the pieces first. So I'm going to draw, let's make it 1.5 inches, 1.5 wide. That's going to be the outer diameter. So I'm going to draw this. And then let's say that we want this to be, we could have it like 3 teeth an inch. But let's say 3 teeth per inch. So I'm going to move this up 1 inch, divide this into thirds. I'll just draw these lines to be a simple reference. How deep do we want our threads to go? Well, let's just say let's just do about 0.2. We're just drawing something roughly here. And how we have our crest, we have our root. Let's say now root isn't one of the options that we're going to enter, but it's going to kind of be determined by the other things we create. So let's say 0.1, and I'm in inches, but let's say our root is 0.1. So I'm going to move that there, move it back, and then I want some sort of crest. Let's use that nice 30 degree. And if we do that, well, maybe I want something else, because it turns out that would give us a very pointed, and I want something here. So let's reconfigure, let's say this. If we want to maintain our 30-degree angle, then this needs to be smaller. Let's just cut it in half. So I'm going to move this, lock it right there. 30, 30. I don't know what crest this will give us, but we're going to get that by default. Wait, let me not. I want to grab all these and copy them. Now we can erase some of this stuff. So that's going to be a very thick thread, but that's okay. It'll give us a nice visual. What I need from this is I could select just these elements and sort of copy them over here. These are the pieces I need. This is really deep. I'm not sure how this is going to turn out, but we're going to try it anyway. So if we bring up whirl, what we need is the radius. Now whirl has the option to create a taper. We do not want to mess with that. So again, we're making a 1.5 diameter, but this is radius. So I need a 0.75. And then we need the pitch and some of these others. Well, with this open, I can't measure or do things over here. So I'm going to cancel this and quick draw myself some references. So with the dimensions, so I've got, that's the pitch. This is the tooth length. This is the tooth height. And this is the, oh, I forget what it's called, but this is the edge. Yeah, edge height. By the way, I get confused all the time at like, well, what's the tooth length and what's the tooth height? I find this is one way to remember it. When you're looking at the tooth, if I look at this as an L, that's the length right here. So that's how I remember length versus height. All right, with that, we should be able to finish this out. So let's go back. All right, our pitch is point. We can probably round all these to the nearest 2 decimal points. We do not want any tapered. This is the number of rotations. So tapered rotations, none. Start and end radius, we want that to be the same. Pitch is 0.33. Number of fixed rotations. Now I find it'll take a little bit longer, but if you know you want, we said we have 3 teeth per inch, and let's say we wanted 10-inch bolt, then we should put in 30 rotations here. Or we can kind of merge geometry later, but you may want to just put it in from the start, at least on this one. To make this simple, I'm going to keep this at 20. That's going to take a few moments. Sections. This is the number of segments in each turn. Don't go crazy, but do turn this up. 60 is a good starting place. Now we're making this 1.5 inch diameter. Maybe I would turn that up to maybe say 80. If I was making a 2-inch or something, maybe I'd turn it up to 100 or 120. But don't go too crazy, because we're going to be creating some small geometry that's going to cause some problems if we go overboard with this. Let me just turn it up to 80. Thread height. Okay, 0.281. We'll just say 0.28. thread length, that's here, 0.2, and edge height is 0.06. Okay. Because this we've got 20 rotations here, 80 sections, it is taking a few moments. That's okay. It should drop it right here at the origin in your model. And let's look at what we got. That looks pretty awesome. The first thing we want to do from this point, I like to run cleanup, extension cleanup. I'm going to run this with my keyboard shortcut from now on, but smooth edges, erase stray edges, repair split edges, merge coplanar faces. Let me run cleanup, and it's reduced the number of edges by a lot. It looks better. I'm going to come in here and reverse that face. All right, so now that we've got this, we need to make it a solid. Before we move this anywhere else, it's based right here on the origin. And so this is going to be great to start with. If I draw a circle, right now we need to remember the number of segments that we put into the whirl, which was 80. But if I pull this up again, it should remember we made 80, and that's very important. Oh, I don't want to hit OK. Now we're going to have two of the same. Thank you. We don't need you. So I'm going to turn my circle sides up to 80, start from the origin, draw out in the red direction, lock it, and then reference this point so that it's exactly meeting up there. The point of this, if we turn on hidden geometry, is we want to make sure that our cylinder is going to match up exactly, as you can see here, with the spiral that we've created. That's going to be crucial. So let me pull this down so that it extends past. Turn hidden geometry back off. I like to come into the spiral group, draw this edge to close up that surface, and come to the top and draw this edge. Now, if we look at this, it's going to draw another one inside here, but that'll get fixed in a moment. Then I take this. If I have grouped this, I ungroup it, I ungroup this. By ungrouping them, it should just naturally merge that geometry that overlaps together, and it should merge all this together. So I'm going to triple click to select everything, group it, and here I would run the solid inspector, which will repair this. But first, I like to come back in and trace those exact same lines that I just drew. You can do this in the opposite order and draw these again after solid inspector. I just find I get a little bit better results if I do them first. So with that, I'm going to select this, go to solid inspector. It's going to fix a ton of stuff for us. Let me show. See, we have all that leftover cylinder inside there. Oops, let me select it, select solid inspector, fix all, and wow. Love solid inspector. Thank you, TomTom. And that's it. We have our solid spiral, and from here we can build out, build this into a bolt, build this or cut this from something else. So let's just create a generic bolt and a generic nut from this, and then we'll call this one good and come back in the next video for some more accurate results. So for this, here's, okay. I'm sighing a little bit because this may work. We may not have to scale this up, but if you've worked with small geometry in SketchUp, you know that sometimes it doesn't want to behave nicely. So here's a case where I might scale this up before we start working on it by 100, maybe even 1000, so that I have this very large geometry that's going to play nice, and then I will scale it back down. So I'm going to create, let's do two things here. Creating just a little bit of a chamfer. And in this one, let's say I want to merge this down. I want to overlap this, so I may want, but I'm going to make it go right to that point. You don't have to do that, but that should give me a nice result, and one that if I need to reference, I know I was referencing that that red edge. So let me merge these together. Before I do, let me just draw a line. As soon as I merge these, I'm going to lose that center reference, and I still want that. It's kind of, I'm just going to draw that. Let me unhide. Okay. I'm going to take these two and use the solid, the solid tools. Merge those into one. And the other thing, I'm going to copy this, paste it, offset it. So we're going to create a taper down here. And I don't have anything specific in mind for this. I just want some generic taper. So I'll make sure that overlaps completely, and hopefully, let's see, is this a solid? Yep. Is this still a solid? Yep. Okay. Let's have a look at what let's subtract this from this. And it gives us a nice little taper. And finally, we need to create these are the outer threads, and we want to create the inner threads. I'll just create a generic cylinder, but obviously any shape we want. So I'll overlap these, move these over here to the side as a copy. Now, here's something to keep in mind. If I do this right now, so if I said, okay, let's take this from this, it does create those inside threads. Here's the problem. Even, we'll scale this back down, but if I want this to work with this, I've just created an exact size reference. I haven't created something that has the tolerance that would be needed both for a real world object and also keeping in mind that I'm going to be 3D printing this, and 3D printing has a little bit of tolerance of its own. So I'm going to undo that. Now here's the other thing. So you might think, oh yeah, well, this is external thread, so it needs to be a little bit larger. So let's just scale this from the middle. And I'm going to scale this up just a little bit. But let me show the problem. You need to scale it carefully. I'll show you why here. That's not going to work. Because we were scaling the whole thing, if I turn perspective off here and show, okay, yeah, that looks good right here, right? We've got some tolerance. But as we scale up, we can see that by scaling the whole thing, we've quickly scaled. We need to scale it in just the X and Y direction. So let me undo that scale. And what we want to do is scale it, and we can hit the modifier keys to scale from the center, but you see we're just scaling it side to side. So I'm going to scale this up by, let's say, 1.03%. And then make sure I do this in the other direction as well, 1.03%. Now, if we look at this again, let's go to the front view. Let's turn X-ray mode on. Now you can see that the height hasn't changed, but we have this version here. I want to point out one little thing. This way of scaling does tend to do this. See how we have a little more tolerance on the crest and the root than we have in the actual tooth. In the next video, the next method we explore, we can create something that has an absolute the same tolerance. This still tends to work based on the tolerance you give it. So it's okay, but just something to be aware of, that if you really had a dramatic difference between your crest and root, you could create a wedge here that may not work very well with this scaling method. Like I say, just something to keep in mind. But with that, we can finally go subtract here from here. If we move this back into place, and I should have been a little more careful. But we can see we've created inner and outer threads with a tolerance that should work for us. Now, again, that tolerance isn't anything exact. That's something that you will have to play around a little bit with. Also, it depends on your 3D printer and your print settings and the how detailed you're printing, all those things. But let's scale this back down. 0.001, because we scaled it up by 1000%. Awesome. Oh, where'd it go? Oops. Let's try that again. One more check. That's a solid. This is solid. We could print these. Of course, to print this, we'd want to turn this around and we drop this down to the bottom. Do we want to put a chamfer on this? Do we want to chamfer the inside? We could continue to do that, but that is how you can create usable, like I say, these, if I printed these out right now, I would get something like I was showing at the beginning. Totally should work together. I think I've given it a decent amount of tolerance that it absolutely work. So in the next video, we're going to explore the version where we create this with creating a helix and then the shape, and we will build that out ourselves. And we're going to do it with some higher degree of accuracy. Great. We covered a lot, but hopefully that makes sense, and that's sort of the foundation that we need moving into the next video. So hopefully that was interesting, and I really do like that whirl extension. It's not as accurate, like I say, as the next method we're going to use. There's some it doesn't always give you exactly what you want, but for these type of purposes, it's fast. It works really well. So try it and let us know what you think, and we'll see you next time. Also like and subscribe and do all that stuff. Okay, bye.